Okay, I've asked Fred to be my designated drinker, so Fred.
I'm honored.
Okay, I'm Pat Riley from Hopkinsville Community College, and this is based on the TV show Man vs. Food. If you're not familiar with the show, it's on Travel Channel, and there's a guy who travels around to different places and eats the local cuisine, does some challenges. Students like how seeing math applies and eating. Students like eating in class. So it's a good combination as a way to teach. So I want to show you some examples that I've used from the show and used it in class. When he went to the Austin, Texas episode, there's a restaurant where you can get a supersized donut. And so you can start talking about different ratios. That's one donut in a box for a dozen. Come on, it weighs 2 pounds, it's got a 14-inch diameter, and it uses enough dough for a dozen. So with that information, you can do some things with circles and areas and volumes. How many regular donuts would it take for one? How much dough is in a regular donut then? At that one, he also did the breakfast taco challenge to see if he could break the record for eating the most breakfast tacos. And a lot of times he gives you a lot of numbers that you can use in this would be a developmental level class. They say that to break the record, it would be 6 pounds, and then each one is 3/4 of a pound, so there's a nice little fraction calculation. They mentioned that he didn't break the record, but he finished in the top 10%, so there's how many people were in it? Did he really finish in the top 10%? San Antonio, the Big Lou 42, it's a 42-inch pizza. He did not try to eat this one by himself. As you see, it takes about 4 people to carry it.
And I'm getting hungry.
Well, just wait. So you can do this with areas. What's the area? Okay. Break it down to a regular pizza, Papa John's, or maybe a local place. So how many of the regular pizzas would it take to be equivalent to that one? And then the next slide, I believe, is going to be their pricing chart. So if you want to get into unit pricing and pound per square inch, which is the best pizza, it actually turns out, even though it's big and it costs a lot, it is cheaper than getting a whole bunch of regular price pizzas at that rate. Next one. Okay, in Atlanta, he does do a pizza eating challenge, he and another guy. And so with the numbers in there, I kind of calculated how fast somebody would have to eat to be able to finish that in time. I didn't get pizza, but I went to the snack machine and got some powdered donuts from the snack machine. And there's a couple of my students who volunteered to try to eat the donuts as fast as they could. And then it wasn't exactly like pizza, but we compared like calories or something to see similar. They would not have been able to do it. I did it an earlier semester. I didn't have the students, and I had this one guy who was a former Marine, and he could eat, he did his share. The other guy didn't even finish his 6 donuts. So we figured out that he said, you know what, I don't even need your help. Just get me anybody else, and I could have done it. I'm kicking myself because in Boulder he went and did ate a bunch of wings. I don't know why I didn't use the New Orleans episode where he tried eating oysters, but in Boulder he had to eat a bucket of chicken wings. 50 wings in 30 minutes, so you can get the students to figure out how fast you have to eat one wing, how many wings you have to eat in a minute. Our students were also hungry at this time, so they said, can we go get some chicken wings? We have a little food service on campus, so I sent them over to buy some chicken wings. So they tried to eat it. None of them could eat it one wing fast enough to get all 50 in 30 minutes. Then a couple didn't like chicken wings. I think they just wanted to get out of class, so she said, can we go to Taco Bell and get some tacos? So we got some tacos, and while they were gone, we calculated how many tacos you could eat in a certain amount of time. You could also do this in calculus at the eating rate. So after a while, your eating rate slows down, so how long would it take to finish if you slow down as you go along? This is my favorite one. In Ann Arbor, Michigan, there's a burger place that talks about the different ways you can order the burger, what you can put on the burger. Okay, there are 4 options for how many patties: 6 cheeses, 9 toppings, 12 condiments. If you say you can get none or all the cheeses, none or all the toppings, none or all the condiments, how many different burgers can you come up with? On the show, they calculated it and put that formula from the show and then said, as calculated by a University of Michigan student. I tell my students that makes it sound impressive, but then we do this in class, and I say don't be impressed by they took a University of Michigan graduate student to do it, because by the next class, dozens of Hopkinsville Community College students will be able to do the same thing, and they can, and they actually have an assignment where they have to come up with some kind of a eating thing that has more combinations, and they do just fine on it. And I think they're impressed that they're doing the same thing that Michigan's doing, and I'm done.
Yes!
I teach pre-algebra students, and I'm trying to give them a perspective of how it goes in the future. Our math league coordinator for New York State is Abe Mantel. He gives 20 questions in 60 minutes with no calculator, and I am my campus coordinator. And our pre-algebra class is with no calculators and no other aids. These are the topics. We try to reinforce multiplication facts, and I am the pre-algebra coordinator. So it lends myself to offer all these problems to my students, and I tell them that this is for calculus students. Here is one problem from fall 2014. I have a 5 by 5 by 5 solid cube that I paint on all 6 sides. I then cut it up to 125 1 by 1 by 1s. How many are not colored? They have pictures in their book to solve this. They have a very similar problem from their homework 2. They are trying to find in the magic square the value of x. Their homework 2 has an empty square they have to fill in. So they are very well trained. Here's another example. When the fraction 1/7 is expressed in decimal form, what is the 2014th decimal digit? They have done these other 2 problems, so I give them this problem and then they have to review. Here is another one. A cylindrical storage unit has a diameter of 12 feet and a height of 25, and there is a red stripe with a horizontal width of 2 feet. What's the area of the stripe? They do geometry at some point, so I give them this problem to play. Here is another one, probability and statistics. There is a fly on one of these dots and can only move one move at a time. What's the probability it will land in a black dot? And it's the probability that it's in a white dot. So that's very easy for them. In how many ways can we obtain $20.15 using only quarters? They have to know that it's an even number of quarters. They only have 2 options per dollar, so 40 ways. So this is time for them to think about it, of course. Here is another one. Which triangle has the smallest area? So that's a very good thing for them to see that there are many shapes that have the same area. We play some tangram at that time too. Here is another one. The mathematician Auguste de Morgan lived in the 1800s, and he said that in the year X squared, I will be X years old. What is the year X? So they have to guess what number they have to use. How many different pairs of prime numbers have the sum of 2015? This is a 2015 contest problem. None of them. 2 odd numbers cannot give us an odd number. Spring 2014, if n is an integer greater than 21 and 21n is a perfect square, what is the minimum value of n? Good time to talk about prime factors that they did in chapter 1. If in a galaxy far, far away, there are 6, 7, and 8-legged people, inhabitants. The 7-leggeds are liars. The 6 and 8 tell the truth, and they tell us that they have 25, 26, 27, and 28 legs. This is my art attempt to 7-legged liars. There have to be 3 liars, so the only choice is that the other inhabitant has to have 6 legs. My friend and I were shooting on this dartboard. I scored 32, my friend scored 90. What is the sum of the missing digits? In an algebra class, they have to add numbers and find the missing digits, so they have a very similar problem. So we get to discuss all of these math facts, and in chapter 3 is when they have to do all of these things with the missing digits, so that's another very easy problem for them. In fall 2013, I have 5 bags. Each one contains 10 gold coins, but one of them has counterfeit coins that weigh 0.1 gram more. what is the fewest number of ways that we can guarantee to find the counterfeit bag? Of course, the answer is 1. I knew this problem when I was a kid with 10 possible bags, because you can do it with 10. And basically, you are going to do different number of coins from each bag so that you will know from the digits what it is. It's never too early to start them and to have them look forward to what math looks like further on. Thank you.
Okay, we want to make sure he's on camera.
Okay.
Is that good, Dan?
Yeah. You want me to move a little bit? A little out? Well, just for something different, I've been taking banjo lessons, and I'm a big Rolling Stones enthusiast, so I'm hoping you'll sing along with me. Play with Fire is about social class in London, and I write math songs and poems, so I hope you'll sing along with me. Okay, here we go. Well, you've got your fractions, and your square roots by the score, but then you'll homework, or else you'll be out the door. So don't mess with math, 'cause you're playing with fire. Yeah. Yes, you've got your conics and quadratics, that's for sure. And your prime numbers are endless. You just cannot count them all. But don't mess with math, 'cause you're playing with fire. Your square roots are not pretty when you don't have perfect squares, and your smartphone cannot help you. Not that fair. So mess with math, Am I done? Okay. Well, let's do this one more. Mess with math, 'cause you're playing with the fire. Okay. But don't mess with math, 'cause you're playing with fire.
Oh gosh, there's another Steve.
But don't mess with
We're playing with fire. What the hell is that? That's Russian. Okay, Mike Long. You're up, Mike.
So I'm Mike Long from Howard Community College in Maryland, and I suffer from this addiction that I've had for many years now. It goes back all the way to my childhood, and it's called I like to go to amusement parks and I like to go to the local carnival. And I would stand at the carnival and look at all the rides and then go home and get out my Tinker Toys and Legos, and I know all of you had Tinker Toys and Legos too, and then you would want to build the rides at the carnival. Well, that's what I did, but then I thought I really want to teach math. So how do I bring together this addiction, yeah, you guessed it, with teaching math and the best of the carnival? It's called Roller Coaster Tycoon. So when I was in graduate school, I kind of became addicted to this game, but it helped me to write a lot of the lesson plans that I had to do because I was part of this grant project where I would go and teach middle school to all of these students. So the big question was, how do I make a math problem out of something like this big steel structure where these trains run fast? And at the time, I didn't even really ride them. I just like to look at them. So yeah, it does look like a nice geometry problem, but after that, I thought, well, maybe, it's kind of boring. And then I realized, oh wow, maybe I could teach some algebra students how to do a little bit of slope. Yeah, and there was just an article published about this in the Mathematics Teacher. Someone once told me that I shouldn't publish it because it was stupid kind of stuff, and then someone else went and published it for me. I was just a little bit ticked off. Oh, and speaking of ordered pairs, did you ever think about this? This was done with a GPS unit, believe it or not. And that's a map of a roller coaster, which I think is pretty darn cool. So anyway, we move on, fast forward ahead a few years, and I'm teaching a methods of teaching class, and I took the
took the class to an amusement park and they're riding on this ride. And as they go across the top of the hills, they start shouting f prime of x equals 0. And when they go through the valleys, they shout first derivative equals 0. And I'm going, oh my gosh, I've got a math problem here. I've got to go home and do something because I'm teaching calculus too. So I came up with this really cool activity. It looks like a worksheet. Now, it's actually a task sheet because I don't like to use the word worksheet, but if you draw this really nice picture here, it actually turns out to be a roller coaster. But you know, we have to think about all the pieces of calculus, so don't forget the limits. You might look at this and go, what does this have to do with limits? Notice the limit from the left exists and the limit from the right exists, and the function exists too. Oh, by the way, it's hanging over on the crane, but it's not complete because you really wouldn't want to ride this roller coaster. At least I wouldn't. Oh, and we can't forget the integrals. I used to give this to my middle school students because I did that in another life too. This is, believe it or not, a speed versus time graph, and I would give them gumdrops and toothpicks and say, make a roller coaster. They would get a little bit ticked off though because they never knew where the turns and the loops were, but it was still kind of fun to watch them do this. Oh, and speaking of graphs, I have this really cool little data pack that I wear. I tuck it in my pocket, then I go ride the roller coasters. That was after I turned 27 years old and decided it was really cool to ride roller coasters. This is the Millennium Force at Cedar Point, if you've ever been to Cedar Point in Sandusky, Ohio. And so now I take this data pack with me everywhere. Anybody in here ever been to Disney World? Have you ever been to Disney World and been to the Hollywood Studios? That's the rocket roller coaster. Imagine walking into a class and saying, tell me the story about this roller coaster. Do I do that? You better believe I do. And they go, oh wow, I've ridden that ride. Do you have this ride? Do you have that ride? I have many rides, as a matter of fact. And I've ridden them all. And just for the record, that's lifted from Hershey Park's website, but I don't have to worry about the copyright because I wrote all the activities. So anyway, we go back to algebra class, and I love to do this activity with my students. This is they're actually all the Hershey Park coasters with the number of seats that are on each ride. It says, you know, so which one would have the highest hourly capacity? And they sit there and scratch their head and go, oh wow. Well, how about if we go and collect some data? And they go, oh wow, there must be some kind of a lurking variable in there. Yeah, it's how fast the ride operators are working. That's what the lurking variable is. And actually the log flume sends more people down the track per hour than any of the roller coasters. Oh, and then we can't forget the circular rides, because if you ask the students to make a function or graph a function involving a circular ride, you know what they're going to draw. Of course, they're going to draw a circle. Oh, yeah, try it, it happens. But if you ask them to do height versus time, it's a sinusoidal. If you ask them to distance versus time, you get a nice linear function. And then once an amusement park allowed me to do a really cool thing for writing a few activities for them. I took a ketchup bottle and filled it with sand and rode the scrambler, and believe it or not, check out the function that comes up. That's not the exact one. The exact one actually had 27 pedals, and I made a mess under the ride. But anyway, oh, and speaking of rational functions, we can't leave out the rational functions. It's a real simple task. Send my students to the amusement park, count the number of arms on the ride, count the number of degrees between the arms, you get a really nice rational function. Kind of looks neat. Oh, and then there's even a modeling task. Yes, that's a modeling task in just like MP4, not like all the rest of the mathematical practices. This is, well, when are you actually going to get on a ride? Because it's a nice little queuing problem. And finally, I like to look at my own mathematics, because this summer I rode my 230th roller coaster, and you better believe I keep the data on all of it. Thank you.
Son Nguyen, yes, son.
Thank you, Fred. So I'm the new member of the math faculty at Coastline Community College, and that's thanks to Lisa and Fred, of course. So my first example for common mistakes in algebra really need no introductions. We're talking about adding fractions straight across. And I heard some smiling back there. This is definitely a math crowd. You guys love this too much. So, well, we always tell our students some variation of this line, right? And how do you know that you like this too much? Not only you say this in some variations, you actually say in multiple languages like I did, right? So, at the most fundamental level, what I really want to know is, why do students make these mistakes? The one that I ask, they always tell me, I don't know. And is it possible in some way that we can unprogram this mistake? If we could, that's one less problem to deal with in the future, right? My second example comes from the south side of rational expression. we have simplifying fractions. And sorry, Eddie, I believe I got your name right. A cat just died, right? Well,
Sorry, you're okay. You can be
okay.
a ways away.
We always say that
Yeah, it's perfect.
there's no such thing as bad questions, right? Well, here's one of my bad questions just to have. How many of you guys have seen this mistake before? Oh, there are too many. So, what do you do to help your students when they see this kind of mistakes? Believe it or not, my math lab helped me quite a lot. I don't think we have any my math lab people in the house, right? Thanks to them, a student of mine actually asked this question. And of course, this promotion is not paid for by my math lab, believe it or not. My third example comes from the northeast of polynomial. Here I give you distributing exponents into the parentheses. Now, all of us at one time or another have had a student, I would call him Johnny. And Johnny works really hard. Well, at least Johnny thinks he works really hard. Hard enough for my class, definitely. And we sit down and work with Johnny, trying to help Johnny to come through. Please, Johnny, listen to me. Don't make this mistake. And Johnny would nod his head, yes, 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 I know. And guess what? Exam time comes around, Johnny did exactly the same thing. Only if we're just working in a few of characteristic 2, then Johnny wouldn't have an issue with this, right? But unfortunately, R is so mean. So why do I want students to study algebra? Well, our goal is probably to pass them along, making sure that they're successful in the next class, but most importantly, they're successful in life. And we're trying to get them to stay away from these mistakes so that they don't make them on the exams. But perhaps there's certain things that they just have to make, which is mistakes like this. And if that's the case, why can't we try to help them learn from it? Most of my students, my algebra students, when they make these mistakes and you correct them, they're really fast at either crossing it out or erasing it out just so they don't have to see it again. It's like a nightmare. But it's not. It shouldn't be a nightmare. They can learn a lot from it. At least, I think they can learn a lot from it. So at the end, why do I want Johnny to learn algebra? Well, depends. For me, I want Johnny to learn algebra because I want him to know it's okay to make mistakes. We all do. I have. All of you guys have, right?
Right.
But I do want Johnny to really understand it's not okay to make the same mistake over and over and over and over. Thank you very much.
Oh, I can take his drink. All right, John. All right, son.
Oh, you want mine again? Okay, I'm back. When Fred sent this out, I said, I got 2 ideas. Which one do you want? And he said, well, send me both of them. Let me see. And then he said, let's do both of them.
Absolutely.
So, my favorite math toy, the Nerf guns. Okay? If you have the chance to get these, and this is not a commercial presentation. I got dinged yesterday morning, I think, for they're cool. Okay, it's really good. Here's where it started. A few years ago at AMATYC, I went to a session called Bears in Space, and it was about shooting gummy bears on a little catapult and measuring the angle and how far they went. So I said, great, I love it. That's going to work good for me. So I had the students make their own catapult, get their gummy bears to launch them, and then in class they would measure the angle and measure how far they go, and we'd do that as a big project in class. And so they did. I didn't give them guidelines. They brought their own catapult, whatever they wanted to use, and it did not go well. Their catapults were not good. The gummy bears kept sticking to the catapults and wouldn't launch. They would break. Some of them broke. They didn't have a backup, so I said, oh, that was a good idea. It didn't work. I happened to be at Walmart one day, and I noticed the Nerf gun and how they worked. I said, hey, that's much easier, much more consistent, much easier to measure. So I bought a few Nerf guns and brought it, and that's a picture from the internet. I didn't buy all those. But it turns out, even though I bought it for that one reason, I've found there are many uses for this in many other classes. And let me go through a few of these. I'll start at the lower level courses, the beginning, the developmental classes. One thing I have them do is you talk about distance equals speed times time, a simple problem. So one student would sign up here, get ready in the back, and they would shoot it. And they would time how long it would take to get there. They measured the distance. They could figure out how fast it was going. In intermediate algebra, using the falling object formula, you can measure the initial height. They use their phone to time how long it's in the air. It hits the ground at 0. They can solve for the initial velocity, so they can figure out how fast the darts are exiting the gun. Then they get to college algebra and we talk about calculating the vertex. So we redo that calculation, and then they can figure out how high the darts went in the air once they've got the initial height and the initial velocity. One time I did it, and two groups were complaining because they didn't get the same answer. Well, they didn't have the exact same gun and exact same dart, so I had them do it side by side, and sure enough, the dart's distance was about as far as their answers apart were. They thought that was amazing that the math actually worked. Trigonometry, I haven't used this much in class because I mostly teach trigonometry online, but I have had some students, I suggest it, and they send videos when they do their projectile motion. Statistics, this is really good for collecting data, especially at the beginning when you need data to collect. When a class sees you bringing a box of Nerf guns in, they know something fun's going to happen in that class. So we measure how far they are from a target on the board, how high it's in the air, how long it's in the air. Here's a plot where you can kind of see the data leveling off after they take repeated averages. There's a lot of calculations there. It's not important. But there's a lot of statistics that you can do with data collection. You can use as a good way to talk about the standard deviation. Some darts are much more solid and travel straighter. Some are a little flimsier and don't. You can talk about the difference in standard deviation, how consistent things are. When you get to the hypothesis testing, different shooting styles. And I always ask, what are some good styles? The military style, someone always mentions gangster style, cowboy style, quick shot. Some that have been in the military get on the ground and do it from the prone position. So I have them shoot it in different styles, collect the data, and see, is there a difference in the accuracy in different styles? They really enjoy that, and they produce good work. This is an example of a student's work that they turned in, as was the previous one. And then going back to where it all started with the regression analysis, they measure how high up the angle is, give them a protractor, they measure that, they shoot it, figure out how far it is, and then one time I give them one of their projects is they have to hit a target. Okay, I tell them you can collect the data however you want for a couple weeks. Once you've got it, bring it in here. If I look and see that the data does look reasonable, I'll put a target out there, and they got to try to hit the target. The closer they get, the higher grade they get. A lot of other faculty on campus have started using it. A lot of times the presidents and the deans say, hey, we've got a program with the schools. Can you do something with your Nerf guns? I don't think they know what I do. They say, do something with the Nerf guns.
Yes, welcome back, Sophia.
He has scheduled me after Pat twice. All right. So our NISMATIC keynote speaker was Julie Miller from Daytona State College, and she gave us this awesome idea for this presentation, and I thought it was pretty cool. So I started showing my kids videos. So the scarecrow gets a brain. He says, the sum of the square roots of any two sides of an isosceles triangle is equal to the square root of the remaining side. There he is. And then he says, oh joy, I've got a brain. can tell that actors do not know math because they didn't laugh at this one. Star Trek says, it has an auditory sensor. It can in effect hear sounds. By installing a booster, we can increase this capacity by the order of 1 to the 4th power. Yep. Okay, the next one. The movie A Serious Man. Also, the answer to the equation D in P is equal to the square root of bracket P squared minus bracket P squared, which is also equal to the square root of H over A squared. Yep, the constant function. The next one, Fox News in 2012. When it comes to landing the nomination, Palin is at 70%. Patricia Heaton plays for $50,000 for 2 charities, a pregnant woman advocate group and something else. The question, if a euro is worth 150, 5 euros is worth what? 30 quarters, 50 dimes, 70 nickels, or 90 pennies? This is her reaction before the answers popped up. She called her husband, who didn't manage to answer. Simple math, this guy is going for $16,000. He did not answer the question. It cost him $15,000. Which of these square numbers also happens to be the sum of 2 smaller square numbers? 16, 25, 36, or 49? This is the audience. They also polled the AOL audience online, who had very similar results. He did go with the audience. Yeah, Nikki from New Orleans, Louisiana. What is the minimum number of 6-packs one would need to buy in order to put 99 bottles of beer on the wall? Okay, this is another one. How much daylight is there on a day when the sunrise is at 7:14 a.m. and the sunset is at 5:11 p.m.? 9 hours and 3 minutes is her answer. This one. Which of these kitchen items most clearly resembles a hemisphere? Salad fork, cookie sheet, spatula, or a cereal bowl? Okay, Big Bang Theory. Sheldon tries rock climbing. So they are trying to rock climb, and he's with a friend he's trying to become friends with. He says, oh, this is not bad. It's like vertical swimming. You are halfway there, the other person says. Sheldon panics. Are you all right? Not really. I feel like an inverse tangent function approaching an asymptote. That's a very good explanation of what it means to approach an asymptote. He says, are you saying you're stuck? What part of inverse tangent function approaching an asymptote do you not understand? I understand all of it. I'm not a moron. That's it. This is where you can find the videos. Thank you.
I brought the tequila and started the tradition. Okay, so I really appreciate Pauline Chow talking about Mount Everest because I'm a big OER advocate, and so I wore my OER t-shirt. I mean Mount Whitney, whatever, because that's when I reached the top of Mount Whitney this summer. So I wrote a textbook, which is an open ed resource. We've been using it at De Anza College, and Irene, actually, that was the book that she has been using, University of Minnesota. We've saved at my own college over $3 million in textbook fees. But that's pretty amazing. But I was trying to figure out what else could I do, and there's a lot of stuff I can't do, and we need innovation. And we need innovation so the students can learn more, and we also need to sustain the nonprofits, because nothing is free. In fact, Jason Pickavant said OER is free the way a puppy is free. That's my son with his free puppy that he got from Animal Rescue, which is wearing a 49ers shirt. It also has the Padres shirt, and it also has a Steelers shirt, along the other things to dress up. So I was trying to figure out, why do we want to partner with the for-profits? Because if I'm an OER advocate, then it seemed as a traitor to partner with the for-profits. But these are a lot of the reasons. And so I use the Creative Commons Attribution License, which means that for-profits can use the book and use all the data without paying royalties. They just have to do attributions. What's that? Oh, I need another one. Are we being a sellout? So I want to tell you, I'm going to talk about some examples of partnering with for-profits, and I want to demonstrate why it's important to do so. But I am not doing a vendor demonstration, because at AMATYC, if you're doing a presentation, you cannot be doing a vendor demonstration or promotion or whatever that is. So here's Apple. Apple took my book that I co-authored and OpenStax publishes, and they made an iBook out of it. So you can use your finger and you can go over and highlight and you can write notes to yourself. They sell it for $4.99. So students can have the book for free, but if they want the iBook, they can use that. They can get the solution, so they press a button, so they have formative assessment on themselves without me knowing what they know or what they don't know. Again, it's optional. Here's WebAssign. Oh, I see Jack. Jack, wave. Wave, wave. There's Jack from WebAssign. That's an online grading system. When I did my first talk on OER at AMATYC in, I don't know, 8 years ago or 7 years ago, several faculty said, that's great, I'd love to use an open ed, but there's no way I'm going to grade homework ever again for the rest of my life. So I went down and I said to WebAssign, hey, would you be interested in working on an open education resource? It matches to the textbook number of the problem in the book, so students know exactly where they're going. They get numbers in red, so in the book there are black numbers, they get red numbers, which are different. Every student gets a different problem. There's also a show me button where you can do a problem that's very similar to that. And that works out really great, and the students say, wow, I'm really learning a lot. XYZ, I saw Pat McKeague around here. Is he still here? Well, he's left, but go and say hi to him anyways. So now they're partnering with OpenStax, which is the nonprofit as well. By the way, OpenStax is part of Rice University, so it's an educational program. And they're doing a different thing where you pay a license fee for a year, and you get free access to all the homework for all of these OER textbooks. So again, it's a partnership that's going on between the nonprofits and the for-profits. So I asked my students, I always do formative assessment for my students. I asked them 4 questions. What's going well in this course? What's not going well in this course? What can you do to help yourself? And what can I do to help you? And I've now added extra credit is not an option on that part. And over again, the students say what's going really well. I thought they were going to say, I love the way you teach. You're such a fabulous teacher. Class is so engaging. But no, they say the homework is going well because it helps me to learn more when I can go online and I can try these problems and I can get all these different parts. So the benefits that the students have is that these are features that I can't do. I can't do all these technology enhancements because even though I have a minor in computer science, everything I did was using punch cards. They don't use punch cards anymore, so I'm a little bit outdated. So the big part that I'm interested in and why I do this is it's increasing student learning and success. I don't care that companies are making money because that's what they do. I'm interested in my student learning, and I make money by getting salary as a teacher, and I seem to be doing pretty well. So this is how because I could buy tequila and not charge it with AMATYC money. So for sustainability, this is just one example of a partnership. This is the WebAssign, but everyone else has them where you pay a fee and some goes back to the nonprofit to keep it going. I'm interested, the bottom line is I'm interested in what's good for my students. How are they going to learn better? If they're not going to say that I'm the best thing that's happening in their class, at least they can have something else. Goodbye.
Okay, I'm Amy Kong. I'm from Helena College, Montana. Just a quick survey. Anyone here, you teach online classes? Yeah. Okay, anyone here, you haven't used Google Hangouts before? Okay, anyone here, for those who use Google Hangouts, have you used it for online teaching? Okay, so good. Okay, so just recently I started teaching more online classes. So that's why I'm looking into more tools so I can create more interaction with my students. And so one tool I found is really useful is Google Hangouts. With Google Hangouts, you can video your student, and so many times a student call me on the phone, and then they, I really want to, actually the many moments, I really want to know what you're watching, what you're actually looking at on your computer, and I also want my student also know when I have something on my computer, I also want my student to know, what I'm looking at. So with Google Hangout, you can screen share with each other, and also you can do a group discussion with more than one student, and you can also broadcast your online lecture in real time. And so what you need to do, step one is you need to have a Gmail account. If you haven't have a Gmail account yet, I really recommend you to create one, because actually many online tools like Desmos, a calculator, if you have a Gmail account, you can save a lot of things in it and share with many people, with the students. And step two is once you have your Google account, it will comes with the Google Plus will come with it. It's like a social media like Facebook. And then when you sign in to Google Plus, then you will find a Hangout frame. And then all you have to do is just click start a video Hangout. And so then you can video call with the student. And then you guys can not only you can see each other, and you also can share the computer screen. And so once you log in to Google Plus, you click Google Hangout, and then you just click, there should be a video call icon, then you just click video call, and then it will start. All you have to do is just put in your student email address, and then once you're in it, not only you can see your student, but there are some more features you can use. You guys can also watch a YouTube video together. You guys can look at the Google document in Google Docs together, and not only you can look at the screen together, but you can also talk to your student at the same time. And you can also broadcast your lectures in real time. So it calls Hangouts on air. And so you can, not only you can broadcast it in your Google account, but you can also broadcast it real time on YouTube. If you have YouTube channel, you can automatically save it in your own YouTube channel. And also you can also customize most of the settings. And so all you have to do, again, you need to log in to your Google Plus account, and then you click create a Hangout on air. So when you click it, there should be some boxes you need to fill in information. So you just need to click, what your lecture is about, and when you want to broadcast it, you just fill in all the information, and then it will give you, then Google Hangouts will give you a link. So if you have been to webinar and you'll receive a link, so at that time, that day, you just click the link, then you can watch the webinar. So it's actually similar. So once you get the link, you send the link to your students, and then so on a certain day, certain time, when your student click the link, and then your student can watch your lecture online in real time. And then this is actually, Google Hangout is actually really user friendly. Not only on computer, you can also download the app. They have an app in you can download it with any tablet, and even your smartphone, smartwatch. So imagine you can, talk math with your student on phone anywhere you go. I'm sure how much you like it. So your student actually can call you anytime. You can look at each other and share the computer screen. And I'm not sure how useful it is for teaching, but there's also there's stickers, emoji. When you talk to your student, you can add some of the stickers. But I'm not sure how much is really useful, to teaching. But anyway, so now I know this is a really short presentation, and so if you're really interested, there are actually lots of resources online and to teach you how to use it, and it's really, really, really user friendly, and it's really easy. I'm loving it, and my students loving it, and so thank you.
Yay, Kathleen, you ready?
Yep.
Ready for your shot?
Here we go. So I'm here to talk to you about how to enliven classroom doldrums with quick and easy games. Now, I'm never boring. Are you ever boring? Never. No. Your students never look like this, right? No. Well, maybe right before a test and they're really stressed out And so they kind of look like they're asleep because they're stressed out. Maybe that's what it is. So a game is going to get them to focus, it's going to get them to make some noise, and it's going to get them to have fun and release that stress. Am I talking right?
Yeah,
okay.
you're good. You're good.
And so it really does help them to have fun. And my favorite part is we make some noise and we get the teachers next door to be jealous. And you can make one up in advance. So I'm going to talk about advanced games. So here's one that's really fun. You take an envelope, you put coins in it, and then you make a problem, a coin problem on there. Coin problems are really silly, but they're really fun when you put them in an envelope and the students shake them, and you say you can't open the envelope till you solve the coin problem. And then if you get it right, your group gets to keep the money. And if your team has the correct solution using algebra, right? And if the answer's right, they keep the money. And I also do little things in the end. The team with the most money wins, and they have a lot of fun. It's a real icebreaker, good thing to do before a test. What else about it? There we go. So PowerPoint Jeopardy is also really fun, and you can get that anywhere online. You just do a web search for PowerPoint Jeopardy and up it pops. And it's really fun if it has music. But you have to, by hand, add your own problems to it, right? So you have to go in there and add a lot of problems. What if you need a game fast, right away, right now? Your students are stressed out, they're bored, they're tired. If you add an element of randomness, like dice or cards or spinners, you have a game. And so you can really quickly make a game up if you have any of those in your bag. I usually have cards in my bag. So we can make a polynomial multiplication game up really fast. I did this very fast. So I put a problem on the board like that, and then I gave every group 10 cards, just randomly from the deck. And I said, if you simplify it correctly, you can discard the cards in your hand that equal the last number. So the group could, if they got it right, discard the group cards adding up to 10. So that means they could discard a royal card, a 10 card, or like 3 plus 2 plus 5. And they could discard that. And that was working really well, except some students were stuck with cards they couldn't get rid of. So I did a bonus round where you could get rid of any card you wanted if you did a hard problem. And that was, I just made that up on the spot, just from having a deck of cards in my backpack. So that was really fun. And you could modify it for integer arithmetic, right? You could do reds negative, blacks are positive. You could modify it for a different course, a different kind of problem. It's pretty quick to modify. But if you don't have either of those two, you could use virtual dice. I love these dice. They have as many sides as you want. You can click on that in the PowerPoints that Fred has, but you can also just Google virtual dice. And up it pops, and they let you customize it. So I put like 0, 1, -1, 2, and I put the students in groups. They're working on like a test review sheet. When they get 4 problems right, they come up and roll the virtual dice. And if they get a 0, like the really fast groups come up and roll a lot, but they get 0. And then they don't get to go. Or they get -1. Somebody told me that's really unfair. Putting -1, they have to go back 1. But they laugh. They think it's funny. And then they advance along a board that you've drawn on the whiteboard or on the chalkboard, and you can just really quick draw that board. And so those are a couple really quick and easy games to play. I do more complicated games also, but this is a way to do really fast and easy ones. Thank you.
So Nancy's going to have some closing remarks. Is that right, Nancy?
I'm going to tell you what. I hope you were all entertained as much as I were and learned so much. This has been a fabulous evening, and I thank all of you for participating. I thank the presenters. I thank Dan for all of his work taping. I thank Fred for his organization. I thank Mary Beth for running the computer.
So now I want y'all to go out and enjoy New Orleans. And see you in the morning.